This is an additional video for the students doing either the higher or the triple science course. You still will need to watch that previous video, but we're going to start off by looking at this question here. A car is going around a roundabout. Explain why it's accelerating even if it's moving at a constant speed. So the first thing we need to remember is the definition of acceleration. Acceleration is a change in velocity. So if something's velocity is changing, it can still go at the same speed, but if its direction's changing, its velocity is going to change. So because these cars are going in slightly different directions, as they move around the roundabout, their velocity is going to change. So the correct answer, why is a car accelerating even if it's moving at a constant speed? You need to first of all say what acceleration is. So acceleration is a change in velocity, and then you need to explain why its velocity is changing. So because the cars are moving in different directions, their velocities are constantly changing, therefore they are accelerating. The second thing that we're going to look at is another vector quantity. So this is just on the higher or the triple science course, and it's called momentum. Momentum is when you have a mass and a velocity. So if we look at these two objects here, we'll have a truck and a car. If they are both moving at the same velocity, the truck would actually have a higher momentum, and that is because it's got more mass. So momentum is mass times velocity, and the reason why it's a vector quantity is because velocity has a direction. So if it has a direction, it is also a vector quantity. So momentum is also a vector quantity, just like velocity is. And the last thing we need to look at is this equation here, v squared minus u squared equals 2 times a times x, where x is the only letter that we haven't seen so far, and that represents distance. What I suggest that you do is you pause the video and you have a go at this question here. It does have 2 different points, so how long would it take, but then more importantly, how far does it travel? So we need to figure out x. Pause the video now and see if you can do this. Okay, so the first thing we're going to do is how long does it take for that train to travel, to stop. So it was going at 35 meters a second. Each second it's slowing down by 0.5 meters per second. So it's going to take 70 seconds for it to stop. The next thing we're going to do is figure out how far it would travel, and the first thing that we need to do is figure out how to solve x. So if we want to solve x, we'll first need to move 2a over to that side of the equal sign. So what we're going to do is we're going to divide 2a by both sides, and that will leave v squared minus u squared divided by 2 times the acceleration. That will get you 1 mark. So we've rearranged that successfully. Now we need to substitute in the values. So v squared is the final velocity. Well, it's going to come to a halt. So that's going to be 0 squared, which is just 0. Take away u squared, so 35 squared, divided by 2 times the acceleration, and the acceleration is negative 0.5. I'm then going to solve that. So negative 35 squared is negative 1,225 meters, divided by 2 times 0.5, so that is divided by negative 1. So during that journey, that train will take 1,225 meters to stop. This last question pulls together all of the things that we've learned in this topic. It really is for the students that are really pushing for grade 9s. If you want to pause the video now and have a go at these 4 different questions here, that would be really, really useful. Part A, we need to use the equation A equals V minus U over T. And we're actually solving for V. So what we need to do is we need to rearrange that to get v minus u equals a times t. We're then going to substitute in the values for a. So acceleration is 200,000 meters per second squared, and we're going to times that by the time that it was travelling down the barrel of the gun, so that is 0.001 seconds. If we times them together, we should get the value 200 meters per second. Part B actually contains some information that you won't know. So if I tell you that information, then you can pause the video again and have another go. So what we need to think about is, so now we know that the bullet is moving upwards at a velocity of 200 meters per second. Gravity actually would pull down on the bullet with an acceleration of 10 meters per second squared. So if we think about, so gravity has a acceleration downwards. Acceleration, remember, is a vector quantity, it's got a direction. The velocity of the bullet is upwards. So how long would it take for the bullet to come to a stop? Have a go now. So one way to answer this would be simply by saying, well, it's going 200 meters per second at the start. It's going to then slow down by 10 meters per second, so 1 second later it'll be going 190, 2 seconds later it'll be going 180. A different way to do this, and probably a better mathematical way of doing this, is using A equals V minus U over T, but then rearranging to figure out that the time it takes equals V minus U over the acceleration. The change in speed, so it's going at 200 meters per second, but then we want it to slow down to 0. So it's going to have to slow down by 200 meters per second, and we're going to divide that by, so that the acceleration would actually be negative 10 meters per second squared. If we solve that, it would take 20 seconds for the bullet to slow down in part B of that question. Part C is actually quite easy. So if we understand that it took 20 seconds for it to stop, it would also take 20 seconds to go back down to the gun. So altogether that would take 40 seconds. The final part, part D, is quite tricky. We have to pull together everything that we've previously worked out. So we need to remember that the final velocity, V, the bullet was travelling at 200 meters per second while it was leaving the gun. We'll assume that it started at 0 meters per second, and we know that the acceleration is 200,000 meters per second squared. So using them 3 letters, we can figure out the length of the gun, so x. And what we'll have to do is we'll have to rearrange that so that x equals v squared minus u squared divided by 2 times the acceleration. We have to solve that. So 200 squared take away 0 squared, which we can just ignore because 0 squared is 0, divided by 2 times the acceleration, 2 times 200,000 meters per second squared. We can then solve that. So 200 squared is 40,000 divided by 2 times 200,000, which is 400,000, will give us 0.1 meters. So the gun length is 0.1 meters. We may then have to change that into centimeters, so that would be 10 centimeters. It would also be 100 millimeters.